Welcome to EDU World Space.
How to derive a Lorentz transform, starting with the idea that it should be a linear transformation between coordinates x, y, z, and time, and the primed frame coordinates. Now, typically, there would be 8 coefficients in that linear transformation. Using the principles of relativity and some simple symmetry arguments, we can whittle it down to just 3 coefficients that we need to find, and they are labeled here as A11. If you were thinking about a matrix, that's where the sub-indices are coming from, A41 and A44. Also notice that we are only worried about the transformation in the direction of motion. So we've rotated our frames so that the motion occurs solely along the x direction. And with the simple understanding that there can be no preferred reference frame or that 2 observers should agree on experimental results, we can throw out the y and z directions. That is, we also have y prime equals y, z prime equals z. And we can, from now on, leave those out of the situation. The 2 equations downstairs, the x squared equals c squared t squared, we'll call that equation A, and the second one B, are needed to preserve the constant c of the speed of light, c, in all reference frames. So the transformations will preserve the postulates of relativity. The algebra gets a little bit hairy, so we'll walk through the steps. Perhaps I won't show all the steps. But basically what you want to do is you want to put 1 and 2. So the steps start with put 1 and 2 into equation B. And that will give us a quadratic. So we'll have to expand some binomials. So what we have there is A11, x minus vt, all this quantity squared, has to equal c squared times t prime squared, which is A41 x plus A44 t squared. Okay, so that's not too hard at this point, but what we want to do is expand those out and then group the x and t terms together. Okay, so expand the binomials and group x terms, we'll say, on one side and t terms on the other. And there'll be a cross term that we're going to have to figure out what to do with, and we'll explain that once we get this rearranged. Okay, so we have basically A11 squared, x squared minus 2vtx plus v squared t squared is going to equal to A41 squared c squared x squared plus 2A41 A44 c squared tx, horrendous algebra here, plus A44 squared c squared t squared. Okay, so nothing too exciting there. But before we can group x and t terms, what we're aiming for is an equation of the form in A. That is, we're going to try to group all the x squared terms together. And we see that we're going to have to equate whatever is in front equal to 1. And on the other side, we're going to be grouping all the t squared terms together. And whatever occurs there, we're going to have to set equal to c squared, which means that the cross terms have to vanish. So on both sides of the equation, we have cross terms. And the cross terms must vanish, must balance each other, balance and vanish. So that gives us one equation. Okay, so there are three coefficients. And what we're going to wind up with are three equations for those coefficients. But what we have basically is minus a11 squared v is equal to, and we'll divide that by c squared, a41, a44. Yeah, the c squared. I've moved it. I like the c's to stick with the velocities. Okay, so grouping all together the x squared terms, what we have is basically a11 squared minus a41 squared, c squared, x squared is equal to a44 c squared minus a11 squared v squared. Okay, this is after grouping. And so now we're going to wind up with three equations for our three coefficients. I'll write those down and then kind of talk through the algebra that you need. It's kind of a mess, but it's pretty straightforward algebra, if not super simple. Okay, so three equations. And they are nonlinear equations, to be aware of that, because of the squaring that we did to find a11, a41, and a44. Okay, so we have three equations. Yeah. Minus v over c squared, a11 squared equals a41, a44. I'll just summarize those. Second equation, we have the coefficients have to combine to give us 1. And the third equation, a44 squared c squared Okay, so like any set of combined equations, what we'll basically have to do is start to substitute in terms of one unknown in terms of others. So I'm going to start with one and sub in for, or solve for a41. Then use that in here. And then this will be a equation. So sub in, and you'll have equation in a11 and a44. And then you repeat. So you'll have two equations in a11 and a44. And let's see what we want to do. I think we're going to be using solve for A44 and then put it into equation 3. Okay, so 3 nasty steps. Let's take a look at the first one. Solve 1. For A41. I'll go ahead and square it, and the result is A41 squared equals V squared over C to the 4th. A11 to the 4th over A44 squared. Okay, so you want to sub this in equation 2. That's sort of the next step. And you get, yeah, a mess, A11 squared A44 squared minus B over C squared A11 to the 4th is equal to A44 squared. And then we want to solve this for A44. And that's the next step, A44 squared is V over C squared, A11th to the 4th over A11th squared minus 1. Okay, and then we want to use A44 in equation 3 and solve it for A11. And that gets to be a little bit messy. I can certainly show how that works. Okay, so we have A44 squared we're starting with that one, and we use that in there. And let's see. Let's put this to the other side just to save a step. Okay, and after some algebra, you wind up getting 1 is equal to A11 squared times 1 minus V over C squared. And so the result of the algebra is that A11 squared is equal to, this should look familiar, 1 over 1 minus V over C squared. So we see that A11 squared is what you call in relativity many times the gamma squared. So yeah, there's some interesting things going on. Now, I'm not going to finish the algebra. It gets really quite a hairy mess, but you've done the hardest part, because the next set of steps is to go backwards. That is, take A11 squared equals gamma squared and put it back into the equation 2 that just has A44, and solve for A44. And you'll find that A44 squared is equal to gamma squared. And now you can back substitute everything. Into equation 1, probably the form that's the easiest to use that you've already worked with. And you get that A41 has to be minus v over c squared, 1 minus v over c squared root in the denominator. And I won't show that algebra. It really gets to be kind of hairy, but it does work out. That's not the hard part. The hard part was sort of figuring out how to go forward and get the coefficients from the information whittled down about the transformation.